Distance along great circles. Distance along any of the longitudes and distance along the equator only among the latitudes are called distance along great circles. The formula used is length of arc equal to theta over 360 times 2 pi r, where r is the radius of the earth. So if this is the globe, it's spherical, and this is the equator. So this is the north-south, the polar axis. So if this is our meridian, which is a line of longitude, okay, this is east of the prime meridian. Prime meridian is the west, so this is a line of longitude. So let's say we have a line of latitude which is parallel to the equator. The equator is a line of latitude from which every other line of latitude is measured. So the equator is 0 degrees. The 0 degrees to the south, that's where the lines of latitude to the south are measured. So from 0 degrees to 90 degrees to the south, and then from 0 degrees to 90 degrees to the north. So let's say this is latitude. Let's say 57 degrees north, and this point are intersected with the longitude, which is let's this longitude 80 degrees. Okay, longitude 60 degrees east, right? And let's say another point intersected with another line of latitude intersected with this longitude, and this will give us a long latitude, let's say 48 degrees south. So you see that both points lie on the same longitude. Both points lie on the same longitude. So the distance, let's call this A, and let's call this B. Now this to the equator, okay, and then to this point. So this is a great circle. This is what we mean by distance along great circle. Whenever the points lie on longitudes, the circle formed is a great circle. So let me read what I have here. So distance along any of the longitudes and distance along the equator only among the latitudes are called distance along great circles. So what will help you to determine whether any particular line is a great circle or a small circle is that whenever the 2 points lie on a single longitude, line of longitude, that means that's a great circle. That means a distance along a great circle. Well, conversely, when it lies on two lines of when the 2 points lie on the same parallel of latitude, then that's a small circle. So let's say instead of what we have here, let's say this is our line of longitude, all right, and now we have, okay, let's say longitude, same longitude 60 degrees east, and now this is latitude. Let's say this latitude 67 degrees north. Now let's say this is point A. This is point A, and let's say this another line of longitude. Now this time around, let's say this is longitude 74 degrees west. All right, and you can see that at this time around, this is the point of intersection, this is point B. Now note the difference between this and this. In this illustration, the 2 points of intersection lie on longitude 60 degrees east, but on this illustration, the 2 points of intersection lie on this parallel of latitude, which has this as the center. All right, so which means from this point to here is the radius of the small circle, which you are seeing here. So this is the small circle. So this is the radius of the small circle. So points A and B lie on the parallel of latitude 57 degrees north. So this is the case of small circle, distance along a small circle. But for this is a distance along a great circle because they lie on the same longitude. When the 2 points lie on the same latitude or line of latitude, it's known as distance along small circles. When it lies on the same longitude, it's known as distance along great circle. The formula used for this calculating distance that lie along great circle is slightly different from the formula used to calculate distance along parallel of latitude, which is distance along a small circle. So when we get to that point, I'll put down the formula on the board and give a little explanation on why that formula is quite different from this. But for now, we are looking at distance along great circles, which is distance along a line of longitude, and the formula uses length of arc is equal to theta over 360 degrees times 2 pi r. The r here is the radius of the earth, so it's not the usual r, because the length of arc formed here is this arc AB. So the radius here is from the center O, which is the equator, to like point E, or which is also equal to from O to B. So the radius of the earth, that distance is known as the radius of the earth, and is equivalent to 6,200 kilometers or 6,400 kilometers in most cases. So it will be given to you. And then one other thing you need to take note of is that theta here is the angular distance or difference. The theta is the angular distance or difference. Angular distance or difference. And you get it when if both A and B, if both A and B are on the same side of the hemisphere, or if they are on the same side, that is north. If B is here and A is here, that means on the northern hemisphere, you subtract the smaller longitude from the larger longitude. But in this case, since A and B are on different hemisphere of the globe, where A is on the northern hemisphere and B is on the southern, you add the two longitudes together to get the angular difference. Same thing if A were on the north here and B were on the south here, you add. But if B is here and A is here, you add. But if A is here and B is also here, you subtract. So take note of that. Mhm. Y and Z are two places on the surface of the Earth along the meridian such that Y is latitude 70 degrees north, longitude 65 degrees west, and Z latitude 38 degrees south, longitude 65 degrees west. Calculate the distance YZ if the radius of the Earth is 6,400 kilometers. Okay. So, okay, so Y is latitude 70 degrees north. It's towards the north, latitude 70 degrees north, and it's longitude 65 degrees west. Longitude 65 degrees west. So this is a point of intersection, and that's Y. So now let's locate Z, and Z latitude 38 degrees south. 38 degrees south. Okay, 38 degrees south. And longitude 65 degrees west. So both points lie on the same line of longitude. So connect both points to the equator. So it's a great circle. Alright. So we have something like this. So this is the equator. Okay. So now this is where we calculate the angular distance. Longitude 70 degrees, 70 degrees north, 70 degrees north, and 38 degrees. Okay, so the distance YC, since it's along the equator, it's a great circle. So first thing first, we need to get our angular distance. The angular difference is equal to, which is theta. Okay, it's equal to, now they are both, y is on the northern hemisphere, z is on the southern hemisphere, so we're going to add together 70 degrees plus 38 degrees. That is equal to 108 degrees. So distance yz is equal to theta over 360 degrees times 2 pi r, and this will give you, so theta is the angular difference, 108 degrees over 360 degrees times 2 times, we're not giving value for pi in this question, so that means we're going to, you can use your 22/7, which is the usual or the known value for pi, but I'm going to express the answer, the distance, in terms of pi times 6. R is the radius of the earth and it's giving us 6,400 kilometers. 6,400. So here, a 0 will cancel 0, and we are going to 2 here, 1, 2 here, 18. Okay, so here's my calculator, and 18 here, 1, 18 to 108, 6. Okay, and 6 times 640, 6 times 640, 3,840 pi, 3,840 pi kilometers. Number 2, an aircraft flew from city A, latitude 0 degrees, longitude 0 degrees. Okay. So the equator, since position of A is latitude 0 degrees and longitude 0 degrees, so these are equator. Okay, so longitude 0 degrees and longitude 0 degrees, point E. Longitude 0 degrees, our polar axis, and which is a prime meridian, and latitude 0 degrees is equator, and that makes it a great circle because latitude 0 degrees is the equator. So that's point A. And then B, to another city B, latitude 0 degrees, not still on equator, and on longitude 18 degrees west. So here it was not indicated whether west or east, but let's take any point. So let's assume that is the west, is the east. So this is the point B on longitude 18 degrees. Longitude 18 degrees east. So I'll connect this point, since the distance along the equator is a great circle. So we have this, and then we have this. So distance AB is along the equator. Alright, so the angular difference, is equal to, since both of them are on the north southern hemisphere, we're going to have 18 degrees minus 0 degrees, which is equal to 18 degrees. So the distance between A and B is equal to theta over 360 degrees times 2 pi r. That's equal to Theta here is angular difference, 18 degrees over 3, 60 degrees times 2 times pi. We say we should be taking pi is 22 over 7, 22 over 7, and the distance of the earth is, so the radius of the earth is 6,370 kilometers. 6,370. Okay, so let's go. Now 18 times 2, 18 times 2 times 22 times 6,370. That's 504, 50,450,000, 5,045,040, 5045040. 360 degrees, 360 times 7, 2520. So 5045,040 divided by 2520. That's 20,2002 kilometers. Okay, so the distance traveled to the nearest kilometer. The nearest kilometer is 2002 kilometers. That's the answer. Number 1. Find distance between A 65 degrees north, 3 degrees east. So A 65 degrees north, 65 degrees north, latitude 65 degrees north, and longitude 3 degrees east. So longitude 3 degrees east. That's A. And then B 25 degrees south, 3 degrees east, and 5 degrees south. So this is B 20 latitude, 25 degrees south. So and along a common meridian, so both points are on the same longitude. So from the equator to this point. Okay, so that's a great circle. So we have alright, so this will give us latitude 65 degrees, and then from the along the equator to point B will give us this angle, which is 25 degrees. So since they are the different parts of the globe, this is the northern hemisphere and this is the southern hemisphere, we're going to add, so the angular difference, angular difference is equal to, which is theta, is equal to 65 degrees plus 25 degrees, and that will give us 90 degrees. 65 plus 25, 90. 90 degrees. Alright, so the distance between A and B, so AB is equal to theta over 360 degrees times 2 pi r. So AB is equal to 90 degrees over 360 degrees times 2 pi is 22 over 7. 22 over 7 times 6,370. Alright, so 90 here 1, 90 here is 4, 2 here 1, 2 here 2. So this will give us 20, okay, 2 here 1 into 22, 11. Alright, so we're left with 11 times 6. 11 times 6,370 divided by 7. And this will give us 11 times 6,370 divided by 7, 1000, divided is 0, so 1000, 10,010 kilometers. So our answer is 10,010 kilometers. Number two, two places on the equator are 7,900 kilometers apart. Measured along the equator, find the difference in their longitudes. Okay, so since the two places are measured along the equator, that gives us a great circle. So with the information we're given, I think that's all. Since the question says that the distance was measured along the equator, so we have to look for the angular difference. So angular difference, theta is unknown. Angular difference, theta is unknown. So the distance apart is 7,000. The distance apart is equal to theta over 360 degrees times 2 pi r. Distance apart is 7,900. 7,900 is equal to theta over 360 degrees times 2 times pi should be taken as 3.14, and then radius of the 6,270. Okay, so this will give us 7,900. So 2 times 3.14 times 6370. That's 2, 4, 14, 3.0, 0.6, 0.6 theta over 360. So over 1 cross multiplying. Cross multiplying. Okay, as this is 4,000. 6 theta. Okay, so when we cross multiply, this will give us 7,900 times 360 is equal to 4,000, 40,003.6 theta. So cross divide both sides by this. So theta will give us 7,900 times 360 divided by 40,003.6. So this will give us 71.09 degrees. So theta is equal to 71 degrees to the nearest degree. So 71 degrees is the angular difference. Two places on the same meridian have latitude 10 degrees south and 53 degrees north. What is their distance apart measured along the meridian? So let's take note of where the distances are measured. If it's along the meridian, that is meridian means longitude, that's a great circle. If you measure it along equator, that's a great circle. Then when you draw your diagram, discover that the 2 points lie on the same longitude, that's a great circle. So this from the statement, since the question says measured along the meridian, that tells us that the distance apart is on a great circle. But notwithstanding, let's still draw the diagram. Alright, so measured apart along the meridian. So let's say this is the meridian, and the first point is 10 degrees south. 10 degrees south. So this is point. Let's call the points M, 10 degrees south, latitude 10 degrees south. Then the other point is 53 degrees north, 53 degrees north, latitude 53 degrees north. Let's call this N. So both M and N lie, points M and N lie on the same line of longitude, which is the meridian. So bring it to equator. Okay, so we have something like this, and so here is 53 degrees north, and here is 10 degrees south. So since this is south and this is north, points M and N are on different parts of the hemisphere, we're going to add the angular difference theta is equal to 53 degrees plus 10 degrees plus 10 degrees, that's equal to 63 degrees. So the distance apart, find the distance. Okay, we're supposed to look for the distance apart. Distance between M and distance M N is equal to theta mercury 60 degrees times 2 pi r. So theta is 63 degrees mercury 60 degrees times 2 pi 22/7 times radius of the earth 6,370 kilometers. Okay. So 63 times 2 times 22 times 6370 176 576 360 times 7 equals 2527. Divided by 2527, 7,007 kilometers. So in the diagram, P and Q are 2 points on the grid circle of radius 6,400 kilometers. So this is a grid circle. It's measured along the equator. The angle subtended at the center by P and Q is 30 degrees. Find two to reach significant figures. A, the shortest distance between P and Q. The shortest distance between any 2 points is distance along a grid circle. So the distance between P and Q is the minor arc PQ. So distance EQ, or this A distance EQ is equal to theta over 60 degrees times 2 pi r. Theta here is equal to 30 degrees over 60 degrees times 2 times take pi to the 3.142, and then radius of the earth. As from the question, we're told that r is equal to 6,400 kilometers. So always take note of the values given. Always ensure that the r value for r is either 6,400 or 6,370. Don't use what you think the value is. Only check the question and use what is given to you. For instance, this question says take pi to the 3.142. So that means that's what we are going to use. If it says take pi to the 3.14, you don't need to add your 2, just use 3.14. But in other cases, you can say take pi to the 22/7. You can see here it says take r to the 6,370. Here it says 6,400 kilometers. So always use what is given to you. This will give us 30 times 2 times 3.142 times 6,400. That's 1, 2, 0.0658 divided by 60 degrees. So divided by 360, this will give us 333351.467. The question says to three significant figures. So three significant figures will give us, this is the first significant figure, the second, the third. So this will give us 3350 kilometers to 3SF. That's A. So B. B says the circumference of this great circle. So take note that this is a great circle. The circumference of the great circle is circumference of great circle. Circumference of great circle is equal to 2 pi r. So where r is the radius of the earth, and this will give us 2 times pi is 3.142, and the radius of the earth is 6,400. Okay, so 2 times 3.142 times 6,400, that's 40217.6, approximately to three significant figures. First, the second, the third. 40200 kilometers to three significant figures. Towns P and Q lie on the same longitude. So P has latitude 50 degrees north. So P has latitude 50 degrees north. So where's the north? So latitude 50 degrees north. And Q has latitude 35 degrees south. Latitude 35 degrees south. Latitude 35 degrees south. Calculate the shortest distance between P and Q along their meridian. So these are the meridians of point P, and point Q. So along the meridian here, so we have this, the arc. So this is PQ. This is line equator. So P is 50 degrees north and Q is 35 degrees south. Since they are different, since point P and Q are on different parts of the globe or hemispheres, we're going to add. So angular A part says find. Okay, so this one doesn't have A part. So the question says find the distance between point P and Q along your meridian. So along the meridian means on the distance between P and Q on the line of longitude. So that implies a great circle. So angular difference theta is equal to 50 degrees plus 35 degrees, and that will give us 85 degrees. So the distance between P and Q is equal to theta over 360 degrees times 2 pi r. So the theta is 85 degrees over 360 degrees times 2 pi. From our question, partiate again as 3.142, and r is 6,400 kilometers. 6,400. So 85 times 2 is 3.142 times 6,400. That's 341.8496 over 360. 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 9,495 equals to. So calculate the shortest distance between P and Q along your meridian. So the nearest okay, let's say so 3 SF and approximate to 3 significant figures 1, 2, 3, 9. So that would give us 9500 kilometers. So 3 significant figures. So that's number 1. Number 2. E. Number 2 A. So A point A 0 degrees north, 20 degrees west, and B 0 degrees north, 45 degrees west. That's on the equator. Okay, so that's 0 degrees. Point A is 0 degrees north, and 20 degrees west. So 20 degrees west. All right. So point A and so point E. So this is longitude 20 degrees west. 20 degrees west. And then B is 0 degrees north, 45 degrees west. So 45 degrees west. 45 degrees west. Point same line. Point B. So longitude 45 degrees west. Alright, so are two places on the Earth's surface. On the Earth's surface, find the angular difference between them. So so we have here AB point A, point B. So the angular difference between them, since they are on the same, both of them are on the northern hemisphere. So angular difference, so A, okay, that's A. The angular difference theta is equal to. So this is a case where both point A and point B are on the same hemisphere of the globe. So once the 2 points are on the same hemisphere of the globe, what you do is that to get the angular difference, you subtract the smaller latitude from, or smaller longitude from the larger longitude. So here, this longitude 45 degrees west, this is larger than longitude 20 degrees west, to be 45 degrees minus 20 degrees, and that will give us 20. 45 minus 20, 25 plus 25 degrees. So the angular difference in this case is 25 degrees. B says, so let me put it here, angular difference is 25 degrees. Okay, so B says, if the radius of the Earth is 6,400 kilometers, calculate the distance between A and B along the equator. So along the equator implies that's a great circle. Take pi to the 3.142, which is what I did here. So distance AB is equal to theta, 360 degrees times 2 pi r. Now theta is an angular difference, which is 25 degrees over 360 degrees times 2 times pi is 3.142, and the radius of the Earth is 6,400. That will give us 25 times 2 times 3.142 times 6,400. That's 1005,440 divided by 360 degrees. That will give us divided by 360, 2792, 2792.89. So we're not told. So how many significant figures? Okay, we're not told. So I'm going to approximate to three significant figures. 1, 2, 3. That would be 2800 kilometers to three significant figures. 1, 2, 3. Oh, yeah, okay, 279. To three significant figures. Okay. So that it was two significant figures to two, not three. To two significant figures. Times A and B lie on the equator. This is the equator. So towns A and B lie on the equator. A has longitude 63 degrees east. Longitude 63 degrees east. And while B has longitude 126 degrees east. Longitude 122 degrees east. Okay. Now, so A times A. This is A, and then this is B. So right. So we have this. Okay. So what do we observe? E. Okay. This is A and B. Now A says what is the distance between the two towns along the equator? Alright. So in the angular difference, distance along the equator is a great circle. So let's get the angular difference. Angular difference. So both A and B are on the southern hemisphere of the globe. So to get the angular difference, we're going to subtract the smaller longitude from the larger longitude. So this is smaller longitude, subtract from the larger longitude. That gives us 123 degrees minus 63 degrees. So 123 minus 63, that's 60 degrees. So the angular difference is 60 degrees. So distance apart, distance A to B along the equator is equal to theta, actually 60 degrees times 2 pi r to pi r. So theta here is 60 degrees over 2 is 60 degrees times 2. What's the value for pi? Pi is 22 over 7 times 6,400. So 60 here, 1, 60 here, 6, 60, that's 6. Yeah, 6. Okay, so next is 2 here, 1, 2 here, 3. And alright, so 22. So we have 22 times 6,400. That's 147. 140,800,800 divided by 3 times 7, 21. And that will give us divided by 21, 6704.776. So I'm going to correct my answers to two significant figures, approximately 6,700 kilometers to 2 significant figures. That's A. So B. B says how far is town A from the North Pole? So town A is here to the North Pole. So it's North S. So this I still, since it's measured, so it's like from A to here, that's a great circle. So the distance A to N is arc. Okay, I say the distance of A, distance of A to distance of A to the from the North Pole. Distance of A from the North Pole is arc. Is arc E N. So A from here to N, and that is a great circle. That is a great circle. So here, the angular difference, remember that A is on the latitude is 0 degrees north because it's on the equator. So from the equator 0 degrees north measured to the North Pole is 90 degrees. So angular difference is 90 degrees. Angular difference is equal to 90 degrees minus 0 from equator, which is equal to 90 degrees. So the distance AN is equal to theta over 360 degrees times 2 pi r. The distance is 90 degrees over 360 degrees times 2 times 22 over 7 times 6,100. 90 here, 4. 2 here, 1, 2 here, 2, 2 here, 1, 2 here, 11. So you don't have 11 times 6,400 divided by 7. 11 times 6,400. 7,704 divided by 7. 1005 7.14 approximately. So two significant figures will give me 1, 2, 1, 0, 2, 10,000 kilometers to two significant figures. Let me make a correction. So E here says 126 degrees east, but I made use of 123 degrees east, and I've already calculated with 123 degrees east. So let me just change to 123 degrees. We always say that in exam, don't change any figure. Changing this part because I've already done my calculation with 123 degrees here minus 63 degrees. So then I'll just have to change this from 6 to 3 so that can correspond to our calculation. But if you do same mistake in exam, it's better you correct your calculation with 126 here and subtract 3 from it and do your calculation again in an exam condition. But I've already started with, I've already done my calculation with 123 degrees east, so I just have to change it here. Alright. Number 2, towns M and Q on the equator are on longitude 70 degrees east and 168 degrees west respectively. On the equator, so towns M and Q on the equator are on longitude 70 degrees east. 70 degrees east. So 70 degrees east. And so town, this is M, point M, and then Q is 160 degrees west. Q is 168 degrees west. Longitude 68 68 degrees west. So point Q, where is, so all we have now, we can represent this as in a circle like this. So north, south. So and okay, so these points, we saw that yeah, both points are on the equator. This, all right, and so we're going to have M Q. So recognize the center O, the equator. So M O Q. That we have here. Right. Point M and here point Q. Okay. So from here to here 70 degrees east, and from here to here 168 degrees. So our angular distance, the angular difference theta is equal to this one is this from the north. These are on the eastern part, and this is the western part. They're on different parts of the globe hemisphere. So we're going to add, so 70 degrees plus 168 degrees. That will give us 238 degrees. If you look at here, the distance between, this is point M, when between M and Q, and we have 230 degrees. That means that this arc is greater than this arc, and since it's the 2 points are on the equator, is a distance that's the distance is shorter, or is the shortest distance possible. So since this arc, what we have here from the angular difference is 230 degrees, it shows that this distance along is not the shortest distance possible. So we need to get the shortest distance, which is this is okay. So in that case, this is the major arc, and this is the minor arc. So to get the shortest distance, we're going to say both the distance M Q is supposed to be the shortest. It's supposed to be the minor arc M N Q. So M N Q. So to get the shortest arc, the angle that will give us 360 degrees, or I can say 238 degrees plus, let's go here, alpha plus alpha is equal to 360 degrees, angles at a point. So we need to get the minor arc. This part from here to here is a major arc. 70 plus 168 degrees will give us 238 degrees. So alpha is equal to 360 degrees minus 238 degrees. Alpha is equal to 360 minus 238. That's 122 degrees. So this is the angle obtained by the minor arc. So this is what we are going to use as the angular difference. So we said distance MQ is equal to theta over 360 degrees times 2 pi r, and that will give us 122 degrees over 360 degrees times 2 times pi. Now take note, in our 2 we're given log pi, so we're going to use a table times pi times 6,400 So because we're given the value for log pi, we're going to use table in this case. So number log, so 122 degrees to 122 degrees to pi 6400. So log 122, it gives us 2.0864. So log 2 gives us 0.3010. Log pi has been given to us. The value for this has been given to 0.4971 out of 400, 1, 2, 3, 4, 3 points. So this will give us 6 out of 400, 3.8062. So everything here is the numerator, so we're going to add 2.0864 plus 0.3010 plus 0.4971 plus 3.8062. That will give us 6.6907. So this is the numerator. And the denominator 360. So 360 log 360 2.5563. So we're going to subtract. So these are denominator. So subtract and denominator. Yeah, denominator 360. So we're going to subtract this from this. So 6.6907 minus 2.5563. 4.1344. The antilog of this will give us 8 log 4.1344. That is 13626. 13626.99. So our answer here is equal to 13626.99. So I'm going to say therefore distance AB equal to, therefore distance AB is equal to 13626.99. But let me see. Did we give, are we told to correct our answers for any significant figure? No. So I'm going to correct mine. So necessary significant figures. So this will give me approximately 13600 kilometers to 2 significant figures. So that's this is 13,600 kilometers to 2 significant figures. B says if town R is also on the equator and town R is also on the equator and it's 2,500 kilometers east of town M. So let's put our point here, R. Let's say this is point R. So east of town M. Connect this together. So here, town M, east of town M, put our R here. So we're looking for this angle. So let's say, the question says we should find what is the longitude of R, so the angle between M and R. Let the angle between M and R B beta. So let's call it beta. So we know that distance M R is equal to angular distance over 360 degrees times 2 times 2 times pi times 6,400. So, and the distance is given to us as 2,500, which is equal to 2,500 is equal to theta over 360 degrees times 2 times 2 pi times 6,400. So 2,500 is equal to theta times 2 times pi times 6,400. Here's over 360 degrees. So this part here will give us 2 times 6,400 will give us 2,500 is equal to 12,800 pi over 360 degrees. Cross multiplying. We're going to have 12,800 pi theta is equal to 360 times this degrees 2,500. So theta equal to 360 times 2,500 over 12,800 times pi. So number, so we're going to have here number log. So here the 360, this will give us 2 points log 2.5563 2,500 3 points 0.3979. So numerator add up together, numerator, so 2.5563 plus 3.3979, 5.9542. The denominator 12800. So log 12800 4.107 pi is equal to 0.4971. So add them together. Denominator 4.1072 plus 0.4971. That will give us 4.6043. To subtract the denominator from numerator, final answer, let's come over here. So denominator, numerator, and right here, numerator, and my numerator is 5.9542. Denominator is 4.6042. So when I subtract, we have 5.9542 minus 4.6043. That will give us 1.3449. 1.3499. 1.3499. So the anti-log will give us sheet log 1.3499. So that's 22.38. So theta here, the value of theta, therefore theta is equal to 22.08 degrees. So now that we know the theta, value of theta, theta here is the angular difference. So for us to get the longitude of r, longitude of r, this is what we're going to do. Theta here, remember that theta is the angular difference between angle M and R, which is beta. So I'm going to use theta here, beta rather. So beta is the angular difference between M and R. But from our table here, you can see that point M and R. So if you have to look for the longitude of R, which means a line passing through this point to the southern pole, and which means this longitude will be greater than this longitude. So beta is equal to, since both of them are on the same southern hemisphere, that means to subtract, since R is larger, the longitude of R is larger than the longitude of M, so the beta is equal to R minus M. That means the longitude of R minus the longitude of M. That would have given the angular difference in this case. So now we are looking for the value R. We've gotten the angular difference, which is 22.38 degrees. So R is equal to B plus, this one comes over to give us M. So this will give us, so which implies that R is equal to B here is 22.08 degrees. Yeah, let me separate these ones like this. So D 22 plus 70 degrees, and that will give us 70 plus 22.38. That's 92.28 degrees. So that's the value for R. So the longitude of R is equal to 92.38 degrees. So calculate the difference in longitude between the following places. This is A, and I'm taking my figure 1. So P 48 degrees north, 25 degrees east, and Q 48 degrees north, 58 degrees east. So in this case, sometimes you may not need to draw your diagrams. So, but in this case, I'm not going to draw the diagram. So now what we see is that both P and Q are on latitude 48 degrees north, which means both points are on the northern hemisphere, latitude 48 degrees north, but on different longitudes. And both of them are still on the same eastern that longitude is on the east, so but on different longitudes. This is 25 degrees east and 58 degrees east. So both latitudes are the same, the longitudes are different. So difference in longitude will give us the angular difference. Difference in longitude or angular difference is equal to, so question says calculate the difference in longitude. So the difference in longitude is equal to, now since both 25 degrees east and both of them are on the east, that means you're going to subtract the smaller longitude from the larger longitude. So this will give us 58 degrees minus 25 degrees. That would be, that's what, 58 minus 25, 33 degrees. I'm going to figure 2. X is 65 degrees south, 40 degrees east, and Y is 65 degrees south, 32 degrees west. So both are on the same line of latitude, but in this case we're told to calculate the difference in longitude. So this is west and this is east. They are on different sides of the globe. So you're going to add difference in longitude is equal to 40 degrees east, 40 degrees plus 32 degrees. That will give us 72. 40 plus 32, 72 degrees. So B, in B we are going to calculate difference in latitudes between the following places. So B1, difference in latitude. Difference in latitude is equal to, so P is 40 degrees north, 50 degrees east, and Q is 30 degrees south, 50 degrees east. Both of them, both latitudes are on longitude 50 degrees east, but this one is on the northern hemisphere and this is on the southern hemisphere. So they are on different sides of the globe. So you're going to add 40 degrees plus 30 degrees to give us 70 degrees. So now figure 2, difference in latitude is equal to x is 60 degrees north, 32 degrees west, and y is 20 degrees north, 32 degrees west. They are both on the same line of longitude, but on different latitudes. But both latitudes are on the same hemisphere of the globe. So 60, since they are on the same side of the globe or the same hemisphere, you're going to subtract the smaller latitude from the larger latitude. So this will give us 60 degrees minus 20 degrees, and that will give us 40 degrees. So basically, whether latitude or longitude, if they are on different sides of the globe or different hemisphere, whether north, south, or east, west, you add to get a difference in longitude or latitude. But if they're on the same side, that is north, north, or south, south, or east, east, or west, west, you subtract the larger longitude or latitude from you subtract the smaller longitude or latitude from the larger longitude or latitude in either case. So that's all.